Hello, this is Dr. Jones. In this video, I'm going to show you how to do a regression problem using a stock index and two different company stock prices that we'll download all that data from using MarketWatch. I'll show you again how to pull that data down and work with it, and then be able to create a regression set of equations out of it, and then to talk about the results that you find. You need to be able to do all of these things for Module 3 Assignment 1. Okay, so remember, when we go to MarketWatch, we're going to download stock price data, but we're not going to purchase anything or subscribe anything. Okay, let's go back and search, and we do S&P 500, and what we're wanting is this right here, SPX. So if you want to just note that down as the symbol for this index, that's the one that we're going to use, S&P 500 index. Okay. Click on historical quotes. We're going to use the last year's worth of data, and we're doing weekly. So we're looking at the last 52 weeks, give or take a week, last 52 weeks worth of data. And as you saw in my video about how to download data, you can, with MarketWatch, download 1 year's worth of data by using this link right here. Remember, you're using 52 weeks, so you have to do looking for the last year, and click on weekly. If you leave it on daily or go to monthly, you'll have the wrong set of data, so please don't do that. So click on weekly, then click on download data, and then open up that file. Now, you don't need all of the data, but you should find a way to at least use the most important part of it. Now, we have to start here with resorting this data, because again, remember, it's in reverse order. So we need to make sure that you have headers on that, clicked on that, and that you're doing date, oldest to newest. Yay, we have it there. So we need to copy that and paste that, and then copy the close, and then paste the close, and then you need to put that as the ticker symbol for that index, so that your labels will come out correctly when you do this. Now, I've saved this as M3A1, my last name, my first name. Okay, and I'm going to go ahead and save that because I want to be sure I don't lose any of my work so far. And then I can just close this. I don't need that file anymore. Go back up into here, and you may remember from the assignment that I want you to choose a couple of companies, and I want you to use your first and last name to try to find the information. Not all first and last names come up with stocks, and please don't try to use all of your name, because it's unlikely that all of your name's in there. But I just want to show you what happens. So we start with mine. So mine is S. I'm Dr. Stephen Jones, so STE. I'm going to start with this and start watching what goes on here. Now you'll notice this one right here is a stock that's a possibility. I add this, That's a stock that's a possibility, and I add this, and there's a stock that's a possibility. Any of those works, okay? I'm going to go ahead and use this one, but I could have used either S or ST. All of those would have worked. I want to be sure that this is a publicly traded stock, and it is, because some things are private companies only, so be careful that you do have a stock. Otherwise, you got to choose a different company in there. So it is on the New York Stock Exchange. You can see the NYSE right there, and then we click on historical quotes, and it's got stock price information. So let's make our selection. We want 1 year. Update that. Click on weekly. Back to weekly, and now I click on download data. Open that file. Boom, boom. There we go. Now remember, first thing I have to do, I need to go through, and if you don't have this up here, that's fine. Click on data, sort, and make sure you have the headers up there, and then click on date, and it resorts it. If I don't do that, then I'll have the reverse sorted data for one stock and not for the index, and that's not good. The only column that I need here is this close column. I don't need the date because I already got the dates over here. And if you look at this set of dates and that set of dates, they're the same, which means I have properly sorted this information. So I can copy and then paste. And then this is STE. And again, I don't need this one anymore. Go back. Now my last name, Jones, Jones. So start J. So there's one. Jacob Solutions up there. O. Uh-oh, I don't have anything. Everything's going towards stock indexes. And it looks like that's the problem. Yeah, if I did JON, it's not coming up with anything. So I need to go back and just do the J. And again, you should be able to, with at least the first letter of your first name or last name, come up with at least one stock. Okay. Now, this one's also traded on the New York Stock Exchange. Not all are. Some are traded on the NASDAQ. And so if you have one that's traded on the NASDAQ instead, don't worry about it. That's fine. You just want to make sure it's a publicly traded stock. It's going to have historical quotes, that it's not a privately owned company, which means it would not have stock trading information like this. Go ahead and choose 1 year, update my results, click on weekly, and download this data. Open that file up, pull it over here. Again, I need to resort this data as headers, choose date, oldest to newest, click, copy, paste, and put my ticker symbol up there for that. Okay. And don't save that. Now, I'm done with data acquisition. I don't need that anymore. What do I need to do? I'm going to make this a little bit larger out there for you to see. Okay. So I don't need to change to dollars or anything like that. I leave the date in date format. It's all perfectly fine. Now I need to open up Regression. Now you should have watched, if you haven't, you should have watched the video on how to get the data analysis and solver plugins for Excel. Now if you need to do that for Google, you can do that, but that's a different video. So I do have students once in a while that are using Work forms of Excel and getting those plugins for them is blocked. Well, that means probably that you'll need to use Google, which means you'll need to go over to Google Sheets and open that up and then use the videos for that program instead. But I have data analysis up, and that's where we pull up regression. So regression is what we're looking at right now. So click on data analysis, go down, find regression, click on that. I've already done some pre-work here. We need to choose for the Y, that is for what we're trying to predict. We're choosing the S&P 500. Don't click like that, because that goes for the whole column, including all those empty spaces. You don't want that. So click on SPX and go down to the bottom, whether you drag it or you use your keyboard arrows, etc. Then you need to choose the first X variable that we're going to use. That's the predictor variable, and highlight that. Make sure that you click on it, that it has labels, so that it will recognize these two things as labels up here. Then we're going to have an output, and I'm going to select for that output right up here. I want to do it next to the data to make it easier for the grader to find my results. Don't put it someplace else. Put it next to the data to make it easier to find. And I don't need to click anything else. Everything else is fine. Now I click on OK. Now I'm going to open this up just a little bit. This is the set of results for this is the predictor, and this is what's being predicted. So how did it do? Well, this tells me how much of the variation in SPX, in the Standard & Poor's 500, that this stock predicts out there. How much of it? Well, what does that mean? Well, if it was 0.1, it'd be 10%. 0.01, it would be 1%. 0.001, 0.1%. Instead, it's 0.00023. So you're looking at a very small amount of the variation, or why the S&P 500 moves and changes up and down, okay, is explained by this stock right here. But I want to be sure that everybody knows I know what we're talking about here, so I'm going to highlight a few spots right here. Okay, so very little prediction. The significance is really bad. How do I know that it's bad? Is because you want this to be as small of a number as possible. So it needs to be no greater than 0.1, which means there's only a 10% chance that my calculations are wrong. You want it smaller than that if possible. 0.05 means there's only a 5% chance that it's wrong. 0.01 means there's only a 1% chance that I'm wrong. Now see, that's different from this. The R-squared tells you how much variation is explained using this variable to predict this variable right here. So that is how good of a predictor is it. This is what's the likelihood that my calculations, that this is a good predictor. What's the likelihood that I'd be making a mistake if I said that's a good predictor? Well, that's pretty good. 91% chance that that is a good predictor, so it's probably not. Okay, so let's go to the other variable. So we click on regression again. Now I need to change the x, so I'm going over to that second predictor, and I need to change where I'm going to put this thing, because otherwise it's going to write over that part right there. So I need to change and put my output to start here, and click on that, and then click on OK. And you can see that now I have the output for the second stock. And what does it say? It says that almost 0.62, 62% of why the S&P goes up and down is explained by this stock right here going up and down. Now, does that mean that this causes this to go up and down? No, 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 no. Not at all. All it's telling us is that this going up and down is a good predictor of this going up and down. So those two, if we did a correlation, those two going up and down, they'd be doing a good job. However, this one doesn't do a good job of it. Now, what's the chance I could be wrong if I said that that's a good predictor of the S&P 500? That's that number right there. Highlight that. So we'll highlight there, and we highlight there. This is our probability. Now you say, well, Dr. Jones, look, this one was 0.91, and this one's 3.41. So that's got to be really, really bad. Remember, in your high school math, when you had E minus something, you were using a way to explain a number when it had too many zeros out at the front. And that means we need to take this decimal point here and move it 12 spaces to the left. Well, then that becomes 0.3 is 1, 0.03 is 2, 0.003 is 3, 0.0003 is 4. Oh, I'm just adding lots of zeros here. 0.00000000341. Well, again, that becomes a really, really small number. What does this one tell us? It says, what's the chance that when I make this prediction, what's the chance that I'm wrong? And the chance is 0.0000003%. Not percent, but 0.0000003 likelihood that this, as a conclusion, is incorrect. So not very likely at all that it's incorrect. Okay, so we're looking at the two variables separately. This one, STE, is a terrible predictor. This one, J, is an excellent predictor of the S&P 500. What about the two of them together? And you might go like, well, that just doesn't make sense. Why would you put the two together? Well, that's the multiple regression. So we'll go back to regression, and now we're going to change the variables and highlight the two variables. Again, we only go down with the numbers, and we highlight the labels up at the top. We just put the two of them together, and that's not a problem because it's going to read those as two separate sets of data for this multiple regression. How well do they act together in making a prediction? We're going to put our output down here below that second regression area and click on OK. Now, because we're using more than one variable as a predictor, instead of doing the r-square as we did before, we're going to do adjusted r-square. Now here's why. We have to be able to understand that we're now using two variables, and there's some kind of collusion from time to time between variables. And it costs us more, even if it's just in time, costs us more to collect two sets of data than one set of data. So the adjusted r-square adjusts for all that extra junk and noise that might be in there. Now, my significance of using the two together is this number right here. And then my two variables right here have these as probabilities. Now, you'll notice up here with single variables, the significance and the p-value were the same. But now the significance and the p-values are different. Well, that's because I'm using two variables. What does this tell me? It tells me that putting the two variables together explains almost 63% of the variation in the S&P 500. Now that's a little bit better than using J alone. Using the two together, I get just under 1% more explanation, okay? But I have to use two sets of data. The significance of using those two sets of data, the chance that I'm wrong is now, notice that E minus 12, E minus 12. So I'm throwing in the extra sets of zeros in there. But notice this one said 0.00003, and this is 0.008. This is a little larger number than that one, and we want the smallest number possible. So this is actually a smaller one. Now, I'm explaining a little bit more information, but I'm not quite as sure of my result. Okay? Why? Well, in this case, if you go back up here to the top, you remember that when I just used STE, my sureness about this thing was really bad. I was 91% sure that I wasn't sure at all. And that's all the change that everything made. I want a small number here, okay? Well, this is a much smaller number for this same variable than this. This 0.07 is less than the 0.1 that I said you at least need to be at 0.1 or less. And this is smaller than that. So it says when you put the two together, this tells a little bit of the story. You'll notice here that I get a smaller percentage, a smaller chance of being wrong than I have when I just use J alone. So this set of two variables together does a little bit better job than just the one variable. So the two, STE and J together, tell a little bit more of the story, and each one does a slightly better job at telling the story than it did when it was on its own. But the two of them together working are not quite as good in terms of reliability as the single J. So if I have the chance to gather 2 sets of data, and it doesn't cost me much in time or money, I can do a slightly better job of prediction. I'm just not quite as sure about my results. Okay, so I tell a little bit more of the story, but I have to be careful on embellishing how much of that story is being told. If I just want a quick and dirty set of analysis, just go for J, because J does a great job of telling the story. But if I have a little more time, I can tell it with STE and J, but I'm just not quite as sure about my results out there. A little more story, not quite as sure about how good that story is. And don't forget, at the bottom, you need to tell what I just said. You need to give an explanation. So you have to tell in 50 words or so what the story is, the explanation of it is. You'll lose points if you do not have a story to tell out there. And just we'll put that up there like that. And pretend that I told that story, what I just said out there. Make sure that you tell an explanation of what these results are. Don't give me the numbers. I can look at the numbers up there. What you're wanting to do is to interpret the numbers for me. Why are the numbers good or bad? And if you come up with 2 sets that aren't any good at telling the story, that's the highlight that you bring down here. Neither of these did a good job, if that's the result. Neither of them did a good job. Or they both did a great job, and putting them together was great or was not as good as either one of them separate. Whatever the story is, that's what you write down in that little box at the bottom. So don't forget that. That's worth several points on this exercise. Okay, folks, then you would just save it and put it in the portal, the assignment portal, before the deadline. Take care now, folks. Bye-bye.